Okay, so for question 20, our x, our y, so still in parametric questions. So our parametric question, now we're going to differentiate y, dy dx in terms of t, find the value of t when dy dx is equals to 1. Then find d2y dx squared by the value of t. So they are related. So for parametric differentiation, first of all, for x, when we want to differentiate dx dt, so for this part it is a quotient rule. Because we can see here is a function t, at the bottom also got function t. So when in fraction like this, we use quotient rule to find the differentiation. We set up our quotient rule, salin yang bawah, differentiate yang atas, tolak salin yang atas, differentiate yang bawah, over yang bawah square. Then differentiate the part that we want. Okay, salin yang bawah dah differentiate yang atas, differentiate t, dapat 1. Okay, salin yang atas, differentiate yang bawah. So differentiate 1 kosong, differentiate negative t, dapat negative 1. So we simplify this because we need to inverse dt dx in parametric differentiation. So we expand this, 1 minus t, here will become plus t, so it become 1 over 1 minus t squared. So when we inverse it, dt dx, we will only 1 minus t squared. So over 1 we didn't write, okay? So over 1 we will not write over 1. So we just put 1 minus t squared. That will be our dt dx. So how about our y? Our y part is 1 plus t. So when we differentiate y with respect to t, differentiate 1, we get 0. Differentiate t, we get 1. So finish for part x and part y. So now we're going to find out what is our dy dx. So for dy dx part, in parametric differentiation, formula will become dy dt times dt dx. So this is our formula for parametric differentiation. Dy dt, we substitute in our result 1. dt dx, we substitute in our result 1 minus t squared. So it will give us 1 minus t squared. So we already find our dy dx in terms of t. Then, haven't finished yet, so the part A here haven't finished. This is question A. We have to find the t if the dy dx equals to 1. So when dy dx equals to 1, means 1 minus t square will be equals to 1. So it will become a quadratic. Okay, so it will become a quadratic because something square. Means something square is a quadratic equation. So quadratic equation, we're going to expand it. T square, then minus 2t plus 1. Then move our 1 to the left hand side, equals to 0. Simplify our quadratic. So quadratic, you cannot escape quadratic with factorization. So quadratic, the rules solving quadratic, it will be going to the, everything go to the left hand side, get it to 0. Then factorize it. Then only you can get the parametric. T is 0, t is 2. This parametric value. So we managed to find these two values. So we look at our question. Is it any status for this t value? So this t value is freedom. It doesn't say cannot accept 0 or what. Okay, so both answer can be accepted. Then, after we find our part A, solve our part A, we're going to our part B. We're going to find our d2y dx squared by that value. So before we substitute value d2y dx squared, we revise the formula. It will become differentiate respect to t for dy dx time dt over dx. So this is our rules. This is our formula. Must follow the rules of parametric differentiation. So for dy dx, we are going to differentiate this. We're going to differentiate respect to t for 1 minus t squared. And then we will time with dt dx. So differentiate this bracket. So this will be our power rule. Power, move to the front. Power minus 1. Inside the bracket, differentiate, we get negative 1. Then time dt dx. dt dx is this. 1 minus t squared. So in total, it will be negative 2, 1 minus t cubed. So we follow the questions here. They say find this d2y dx squared by this value of t. So I have two values. When t equals to 0, substitute inside the d2y dx squared. So it will give us negative 2. So one answer. Another value, when t equals to 2, d2y dx squared, negative 2, and then 1 minus 2 squared. 1 minus 2 cubed. So this will give us positive 2.